All right, guys. So I'm going to go through some examples. The examples are meant to be, somewhat like the things that you guys are going to be doing on the study guide. They're not your questions, of course. I want you guys to do them on your own, but they're meant to be helpful. So anyway, so all this is it's a review of what we were learning prior to our little break here. So. Um, You guys did really well on this stuff, so I imagine you guys might not even need the video. But just in case, let's go ahead and do it. So we learned about how the distance from here to here is 180 degrees, right? And then there's a little bit more right there. How much more is that? Well, if the distance from here to here is 170, and we know that the whole bottom half is 180, that means this little piece in here has to be. So we have 180 plus 10. So that angle there would be 190 degrees. Okay. And on to our next question here. Number 2, radians. Radians are always fun, right? So here's what we know. We know that the distance from here to here would be 3 pi over 2. So now you got to think in radians here, right? So we have 3 pi over 2. It's that full circle there. Well, actually, we don't know what this missing piece is right? We don't know what this distance is here or that angle measurement. But we do know that from here to here is pi over 2, right? That whole thing has to be pi over 2, and we know this much of it is pi over 6. So if we do pi over 2, take away pi over 6, we can find out what that missing piece is right there. Now to do this, we need to get a common denominator. So what I'm going to do is I'm going to go ahead and multiply the top and the bottom by 3. That's going to give me 3 pi over 6 minus pi over 6. And 3 pi, take away 1 pi, is 2 pi. And if we reduce that, we get pi over 3. So this missing piece here is pi over 3. So now we know that the distance from here to here is 3 pi over 2. And we just found out this part here is pi over 3. So I'm going to add pi over 3 in there now. And once again, we're going to need to get a common denominator to combine those things. So I'm going to multiply this one by 3 on the top and bottom, and this one by 2, so they both have a common denominator of 6. So we have 9 pi over 6 plus 2 pi over 6, and that total measurement then would be 11 pi over 6. Okay, so sometimes you got to find missing angles. And add everything all up, right? Go ahead and move on here. This problem is asking us to find cosecant. So it's just basically a trigonometric ratio. Cosecant, as you guys remember, is the opposite. It's the not the inverse, the reciprocal of sine. Sine, as you guys know, is opposite over hypotenuse, right? So that means that cosecant is hypotenuse over opposite. So my reference angle is here. This is my opposite, and this is my hypotenuse. So hypotenuse over opposite would be like this. Now, don't forget, though, if you guys ever end up with a square root on the bottom of your fraction, you can't leave it there, right? But there's our final answer for this particular question. All right, tangent. Tangent is opposite over hypotenuse. I'm sorry, opposite over adjacent. If you guys are forgetting, we learned a little way to memorize that. So Katoa. Right? So tangent is opposite over adjacent. So here's my reference angle. The side that's opposite from that is 8. And the side that's adjacent to that is 6. So opposite over adjacent would be 8 over 6, which reduces to 4/3. All right, moving along here. So this problem here is asking me to find cosine of this angle here, which is 330 degrees. So they want us to find the cosine of 330 degrees. Now cosine is x. We talked about in class how sine is y, cosine is x, and tangent is x over y and all that sort of good. I'm sorry, y over x and all that sort of stuff. But in this case, anyway, we have a cosine is equal to x, and we want to know what's the cosine value for 330. So what's cosine of 330 degrees? In other words, what's the x value at 330 degrees? Well, you have to look at your unit circle. So if you guys look at your unit circle at where it says 330 degrees, you're going to find a coordinate. And that coordinate, the x value for that coordinate will be radical 3 over 2. And so there's our answer, radical 3 over 2. Next one, cosecant. Cosecant of 930 degrees. Wow. Cosecant of 930 degrees. Negative 930 degrees. So first off, we have to turn this 930 degrees into a coterminal angle that's somewhere between 0 and 360. We want our angle to be between 0 and 360. So now, negative 930, is that too big or is that too small? Well, it's too small. We want it to be between 0 and 360, and this is a really negative number. So what I'm going to do then is I'm going to add 360 to this thing continually. Matter of fact, I think I'm just going to use my calculator here to do this and save myself a little bit of time if I can. So let me bring up my calculator. I don't like how. All right, so we have negative 930, right? So I'm going to add 360 to that. That gives me 570. I'm going to add 360 again. That gives me 210. I'm going to add 360 again. And now finally I have a positive angle of 150 degrees. So what that means, and that's how you find a coterminal angle, in case you guys forgot, is you add or subtract 360. So this line right here, even though this is a negative 930 degree angle because of the direction and the number of times we went around, even though that's a negative 930 degree angle, on our unit circle, that is the same spot where the 150 degree angle is at. Okay, now that we know that, we need to find cosecant. So let's back up a little bit. So cosecant of negative 930, well, that's going to be coterminal with 150, right? So cosecant of negative 930 is going to be the same thing as cosecant of 150, because 150 and negative 930 are coterminal angles. All right, now the next thing that we have to do is we have to remember that basically cosecant of 150 is the reciprocal of sine at that point. So what is the sine value at that point? Sine, as you guys might recall, is the y value, right? So at this point on our unit circle, at 150 degrees, my sine value is a half. That's the y value. The half. So sine of y equals a half. That is equal to the reciprocal. Cosecant of 150 is the reciprocal of sine of 150. Sine of 150 is a half, so what's the reciprocal of that? It's 2. Take 1 over 2 and flip it over, you get 2. So that is cosecant of negative 930. Let's go ahead and move on to another one here. Tangent of theta equals radical 3. All right, so for this one, you want to have out your unit circle once again, and you're going to want to look at the tangent circle that we made in class. Tangent of theta. Now these are, by the way, number 7 is a different kind of question. It's a solving question. We want to look on our unit circle, or our tangent circle, I should say, and we want to find where does tangent equal radical 3. And the answer is it equals radical 3 right here, and it also equals radical 3 right here. Okay, now what are those angles? That angle in degrees is 60 degrees, and this angle down here is 240 degrees. So those are your two answers for where tangent of theta can equal radical 3. Let's move on to another one. All right, cosecant of theta equals 2 radical 3 over 3. So first of all, what we want to do is we want to take the reciprocal on both sides. And the reason we want to do that is because our unit circles only tells us things about sine, cosine, and tangent. It doesn't tell us anything about the other 3 trigonometric ratios. So cosecant. Cosecant is the reciprocal of sine. So I'm going to replace this with 1 over sine theta. So cosecant is the reciprocal of sine. Next thing I'm going to do is I'm going to flip this over. So if I flip over the left side, I end up with sine theta. If I flip over the right side, I end up with this. Now we don't like that square root in the bottom, right? So what we learned about that was you multiply the top and the bottom by the square root of 3. And when you do that, you get on the top 3 square root of 3, and on the bottom you get 2 times 3, because the square root of 3 times the square root of 3 is just 3. Those cancel, and we're left with this. So to write this a little more simply, we have sine theta equals radical 3 over 2. So now the question, instead of looking at the original problem, deleting everything, I don't want to do that. I want to, just a minute. So instead of looking at our original question, which was cosecant theta equals 2 radical 3 over 3, we're going to look at this. And we're going to remember that sine theta is the y value. So where does y equal radical 3 over 2 on our unit circle? Well, y equals radical 3 over 2 on our unit circle here and here. That is at 60 degrees and 120 degrees, and those are your answers. All right, next question, number 9. Sine of theta equals negative 2. Okay, well, sine is the y value, so the question now is where does y equal negative 2 on our unit circle? Well, the answer is that's impossible. Sine can never be greater than 1. Sine and cosine both have to be less than or equal to 1. They can't be anything, well, positive or negative 1, I guess I should say. They have to be between 1 and negative 1. It can never be negative 2. So the answer for this is no solution. Cosine, which is x. The question is where does x equal a negative half? Well, looking on our unit circle, x equals a negative half when we are up here and also when we are down here. In other words, that's at 120 degrees and also at 240 degrees. 11, cotangent. Well, cotangent is the reciprocal of tangent. And if I flip over the left side, I get tangent. And the reciprocal of negative 1, well, guess what? It's just negative 1. Negative 1 over 1, if you flip it over, you still get negative 1. So there's that. And so we've got to ask ourselves, where does tangent of theta equal negative 1? So if we look at our tangent circle that we made in class, You're going to find tangent equals -1 here, which is at 135 degrees, and it also equals -1 directly across from that at 315 degrees. There's your two answers. Secant. Once again, we like sine, cosine, or tangent. We don't like secant. So first of all, we're going to remember that secant is the reciprocal of cosine. So if secant equals -2, then that means 1 over cosine equals -2. And then if I take the reciprocal on both sides and flip them both over, I end up with cosine of theta equals -half. And I think we actually did that problem a little bit earlier. Cosine was a -half here and here, right? 120 and 240. All right. So here's a different question. This thing here is asking us to find a cosecant of 100 degrees. And I'm pretty sure this was just basically a calculator question. Now, I could ask you guys to do this on a unit circle, but not when I give you an angle like 100, because that's not one of our special angles on our unit circle. The unit circle only concerns itself with about 16 key angles. This one is not one of them. So in this case, I believe if you guys just look at your directions on the worksheet, it just tells you to use a calculator. But before I use the calculator, you'll notice that there is no cosecant button on the calculator. So what I need to do is I need to change this into the sine. So to do that, cosecant is 1 over sine, right? So instead of finding cosecant of 100, I'm going to find 1 over sine of 100. And so here's how we do that. Calculator, and you're going to push 1 divided by parentheses 100. Sine button. Ugh. Here it is. Close parentheses equals. And I'm getting 1.015. Now, it's important when you guys are messing around with these calculators that you make sure you're set on the right mode. Sometimes we're in degrees, sometimes we're in radians. You guys see this button here toggles us between degrees and radians. And something else rad, but we're not learning that right now. Let's go ahead and move along here. I don't remember the question for this. What does that say? Find the coordinates on the unit circle for each angle given below. So we're on number 14 here. Find the coordinates on the unit circle for each angle given below. All right, so one of the other things that we discussed in class was that the coordinates, which are x and y, right, are cosine of your angle and sine of your angle. So that is to say, when we're at 160 degrees, which would probably be like right about here, the question is, what are the x and y values? They're supposed to be. So all we have to do is we have to find cosine of 160 and sine of 160. Okay. And once again, you just do it on your calculator. So the x value would be, let's see. So the x value would be negative 0.94. Y value would be 0.34. There you go. Those are the coordinates that would be on the unit circle. All right, let's take a look at the third worksheet here. All right. So, special right triangles, something else we talked about in this chapter. One of our special right triangles was the 30, 60, 90 right triangle. We had a longer leg, we had a shorter leg, and we had a hypotenuse. Now, the short leg, whatever that is, the hypotenuse will always be twice as much. So I'm going to put times 2. But if you want to work backwards, then of course you would divide by 2. The long leg is square root of 3 times bigger than the short leg. And once again, if you work backwards, you would divide by the square root of 3. So now when I'm looking at this diagram over here on number 14, we have to ask ourselves, what leg did they give us, or side? Did they give us a short leg, a long leg, or a hypotenuse? And that's the long leg that they gave us. So we're starting here on our diagram, and what you want to do is work backwards to get to the short leg. And to do that, you divide by the square root of 3. So we take our long leg and we divide it by the square root of 3. Those cancel out, and the answer is 2. So that means my short leg is 2. Now, once you know what your short leg is, you can, to get to your hypotenuse, all you have to do is multiply it by 2. So if I multiply that by 2, I can find x. 2 times 2 is 4. So your two answers to this problem would be 4 and 2. Look at another problem. Okay, now in this problem, we are given the hypotenuse. Now, if you want to go from your hypotenuse, what you have to do first is go to your short leg, and you do that by dividing by 2. So b is equal to 9 over 2. And then to go from your short leg to your long leg, you multiply that by the square root of 3. So 9 over 2 multiplied by the square root of 3 would be 9 radical 3 over 2. Pretty straightforward. Moving on here. 45, 45, 90 right triangles are a little bit different. You have two legs that are exactly the same. And you have a hypotenuse. And the hypotenuse is radical 2 times the leg. So if you want to work backwards, of course, you would divide by radical 2. Now in this case, what they've given me on number 16 here is a leg, which means the other leg is also 9 radical 2 over 2. If you want to get to your hypotenuse, what we have to do is multiply that by the square root of 2. So if I take 9 radical 2 over 2, and I multiply that by radical 2, radical 2 times radical 2 is 2. Cancel, and I'm left with 9. So that means that u is 9. My two answers are 9 and 9 radical 2 over 2. Do one more here. I don't like this example. I'm going to try to make it a little bit harder. What I'm going to do is I'm going to say that this is x, and I'm going to say that this is 4. Okay? So what if we had this? Well, in this case, we're starting with the hypotenuse. Now, if you want to go from your hypotenuse to a leg, I wanted it. If you want to go from your hypotenuse to a leg, you have to divide by the square root of 2. So I'm going to have 4 over the square root of 2, right? X. However, we don't like to leave square roots in the bottom, right? So I'm going to be multiplying the top and the bottom by the square root of 2 to get rid of that square root of 2 in the bottom. That gives me 4 root 2 over, those two make 2. And then 2 goes into 4 twice. And so my final answer is going to be x equals 2 radical 2 for this leg right here. And since on a 45, 45, 90 right triangle, the legs are the same, this one is also 2. Okay, so there you guys have it. That's special right triangles. Another thing that we learned was a problem like this. Now this is not a 30, 60, 90. It's not a 45, 45, 90. It's a Pythagorean theorem problem. Okay, so when you have two sides of a right triangle and you want to find the third, all you have to do is a squared plus b squared equals c squared. You just have to remember which one is C. The hypotenuse is the C value. So I'm going to call this A. Doesn't matter which one you call A and which one you call B, but it does matter which one you call C. All right, so let's start with the square root of 15. If I square that, that means you multiply the square root of 15 by itself, which basically you just end up with 15. So a square cancels out a square root, and you're just left with 15. Now, as for this guy here, if we square the 2, we get 4, and if we square the square root of 3, we get 3, so we end up with 12. And if I subtract 12 on both sides, I can get b squared equals 3. Finally, if we take the square root on both sides, we can find out that b is equal to the square root of 3, which is what this last side would have to be. All right, next question. All right, gave you guys some steps for this a little while ago. You're going to notice this is not a special right triangle. You're also going to notice that they didn't give us information for the Pythagorean theorem. But they did give us an angle on the side, and when we do that, we use trig ratios to solve the problem. So the first thing you do is you identify your reference angle, 74. The next thing you do is you label your side. The given side is opposite. The side that I want is the adjacent side. So I have an opposite and adjacent. The next thing I do is I ask myself, which of the following ratios would I use to solve this problem? Would it be sine as opposite over hypotenuse? Would it be cosine as adjacent over hypotenuse? Or would it be tangent is opposite over adjacent? Well, in this case, since we're dealing with opposite and adjacent, we're going to be using tangent. And so our setup will look like this. Tangent, the angle goes here. Opposite is 20. Adjacent is x. Okay, now, next what we're going to do is we're going to go and use our calculators here. I'm going to find out what is tangent of 74. 3.487. And then we're going to solve for x. So to solve for x, the first thing I would do is I'd multiply both sides by x. Then we would divide both sides by 3.487. That should give us our answer there. So we have x is equal to, let's punch it in our calculator. Divide that, 3.487 by 20. And we're getting 0.17. Wow, it's really tiny. Surprise. 0.174. All right. Similar type of question is where they give you two sides, but you don't know the angle. Now, for those problems, most of the steps are the same. You still identify your reference angle. You still label your sides. In this case, we have adjacent hypotenuse. You still pick a trig ratio that has the ones in it that you want. In this case, adjacent hypotenuse is cosine. It's just that this time we have to put a variable in for angle because we don't know what it is. Adjacent over hypotenuse. So in this case, what I'm going to do is I want to get theta by itself. So what we do in this case is we go ahead and we do the opposite of cosine, which is something called arc cosine. So these cancel out, and that leaves me with I'm sorry, not cosine, just leaves me with theta equals arc cosine of 5 over 6. And from there, we're just going to go ahead and punch it into our calculator, and we'll be good to go. So how do you get arc cosine? See if we can figure that out. So we push, first of all, 5 divided by 16, if you're using your cell phone or calculator on the computer like I am. If you're using a handheld calculator, a normal calculator, you might push the arc cosine first. Where's that button? You're going to push second, and then you're going to push trig, and you'll click the cosine with the 1 on it. And so we're getting 71 point. I think on the direction they tell us to round to the nearest angle, so, or nearest degree. So that would be 72 degrees. All right. That ends round 2. Let's move into our last worksheet here. So for this problem set, we're being asked to find a positive and negative coterminal angle. So to find a positive, what we're going to do is we're going to add 360. So if you add 360 to that, you get 5. There's your positive coterminal angle. If you want to find your negative coterminal angle, what you're going to do is you're going to subtract 360. So 5 is my positive, negative 715 is my negative. All right, let's move on to the next one. 14 pi over 9. So again, to find your positive, you're going to add, but this time we're not going to add 360 because we're dealing with radians now. And so we're going to add the equivalent of 360 degrees, but in radians, and that is 2 pi. Now to do this, we're going to need to change that into a fraction and get a common denominator, which would be 9. So I'm going to multiply the top and the bottom here by 9. That's going to give me 14 pi over 9 plus 18 pi over 9, which is 2 carry 1, 32 pi over 9. Okay. And if you want to find a negative coterminal, guess what you do? You subtract 2 pi. Once again, instead of writing 2 pi though, bring that back really quick. Instead of writing 2 pi, I already know what the common denominator is. It's 9, and when I get that, I'm just going to end up with negative 18 over 9. So I'll write that now. 14 take away 18 is negative 4 pi 9. There you go. That's positive and negative coterminals in radians and degrees. Next question says convert each degree measure into radians. So to do that, you're going to take this degree measurement and you're going to multiply it by the ratio of degrees to radians. So for every 180 degrees, that's 1 pi. You're going to need to reduce these things. So first of all, notice I can take the 0 out if I divide the top and bottom by 10, right? And then I can divide both the top and bottom by 2, and I end up with 21 pi over 9. And then I can still reduce. 3 goes into both of those. So if I divide the top by 3, I end up with 7 pi over, and the bottom becomes 3. There's your final answer there. So 420 degrees is 7 pi over 3. Next one we have to convert radians into degrees. Very similar. It's just that we're going to multiply it by the reciprocal of what I multiplied by last time. So I want the pi's to cancel out, so I'm going to put pi on the bottom, and that corresponds to 180 degrees. Pi's go away, right? And from here, probably just use a calculator to get your answer here. Why not? Make your life a little bit easier. So I'm left with 5 times 180 over 12, and let's not forget that it's negative, right? So 5 times 180 divided by 12, and it's 75. So, but it is negative. There you go. I think that does it. I think that's the end of it. On my little example here, I did a little bit extra problems. You guys only have 20, but hope that was helpful to you guys. And this is due Friday. If you want to do this extra credit assignment. Once again, it's a good study guide, though. I encourage you guys to take advantage of it and get used to how we're going to be doing things from now on. Anyway, wish you guys all luck, and we'll see you guys later.